Hello everyone, welcome to the control system. This is part 2 of lecture 9, root locus techniques. So in this section we'll begin with defining the root locus, continue from the previous part. Okay, so consider the closed loop system defined by these transfer functions. As you can see, it has the functions of k. So the location of the poles will be vary depend on the value of k. So if you change the k from 0 to 50, you will be able to find the root locus. Not the root locus, the location of the poles. For example, k equals 0, you have two poles. K equals 5, and you also have two poles, and so on. So until k equals 50. And you can see that this is the location of the pole. Okay, and if you connect it together, it is called the root locus. You can see from here. Okay, like this. So let's move to the next section on the property of root locus. Again, consider the closed loop transfer function for the system defined like this. And then the pole exists when the characteristic polynomial in the denominator becomes 0. That means this term equal to 0 and then k, gs, hs equal to -1. Since this is a complex number, it has the magnitude of 1 and the corresponding angle 2k plus 1 times 180 degree. Okay, so yeah, and this is a complex number, so you can write it in the form of angle condition and the magnitude conditions. So the angle of this is is just this one, the same way as I write here, and the magnitude is equal to 1. So let's consider the system below, the negative feedback system. And well, the closed loop transfer function t is this one. You can combine this block together using block diagram reductions. So in this case, if point S is the closed loop system pole for some value of k, then S must satisfy these two equations, equation 4 and equation 5. So let's consider this point. So if this point is a closed loop pole for some value of gain k, then the angle of the 0 minus the angle of the pole must equal to an odd number, 2k plus 1 multiplied by 180. So if you do the math, and you can see that the angle is minus 70.55, which is not equal to an odd number multiplied by 180. So you can conclude that minus 2 plus j3 is not a point on the root locus. Okay? Or alternatively, this minus 2 plus 3j is not a closed loop pole for any gain. On the other hand, if you do the same calculation, but you change to this point, and then the angle do add up to 180. So you can say that this point is a point on the root locus for some value of k. Okay? And then you can calculate the gains. So you can find the gain k using the previous formula, which is equal to 0.33. So you can conclude that this point is a point on the root locus for the gain of 0.33. Okay, thank you for watching this video.